on the computer. We're going to use Model Studio, which is a point-and-click interface for running SaaS VIA products. And Model Studio is based on the concept of a pipeline. That's how you're actually building your models. Pipelines are just structured workflows of analytic actions. So here's our data. We're going to pretend that we work for a grocery store that's interested in selling organic products. And if you're interested in working along with me, take a look at the link in the description. We've got a link there to the data set. We've got some background information, some demographic information about the customers, maybe variables about prior purchase habits. And we're interested in one binary target, whether or not the customer has purchased organic products in the past. And in Model Studio, in this case, I've already built some models for us. In fact, I've got two pipelines. We'll start here in pipeline 1. Pipeline 1 is pretty straightforward. Didn't take a lot of time to build. It's based on a decision tree and two tree-based models, a forest and gradient boosting. These models are quick and easy to build because they don't require a lot of data preparation compared to other models you might build. We don't need to impute for missingness. These types of models select variables on their own, so I don't need to do anything external to select the variables. The nodes are going to do it themselves. So let's take a look at comparing these models within this first pipeline. In model comparison, we can compare models, in Model Studio, we can compare models within a single pipeline, and later I'll show you how to compare models across several pipelines. So we've got the model comparison node. Let me take a look at the results. Now, the computer can only use one piece of information to pick the champion model, but analysts, data scientists, they often make more of a holistic decision based on a lot of information. They might look at a lot of statistics, maybe a lot of graphical information, and take a look at all the information that they have at their fingertips and make a decision based on all that they're seeing. Model Studio has a default statistic, which is the KS statistic, that's used to pick the champion. So we see at the model comparison table right now that the gradient boosting model is the champion based on default KS. Maybe we want to use misclassification rate where smaller is better. And looking at the misclassification rates, it looks also like the gradient boosting model is the best of the three in this pipeline. Let me maximize that table and take a look at some other statistics. Maybe instead of looking at a decision prediction, maybe I would be interested in predicting a probability or an estimate, in which case I might look at average squared error. And if we look at average squared error, smaller is better. It looks like, again, the gradient boosting model has the smallest average squared error, so it looks like gradient boosting is best on that statistic. Maybe we're interested in ranking predictions. I might look at the ROC index or area under the ROC curve, where bigger is better. And it looks like the gradient boosting model, again, is the best based on area under the curve. It's got the biggest value there. So at least numerically, what I'm looking at is it looks like the gradient boosting model is really the best out of these based on most of the things I'm looking at on the numbers. Well, how about graphically? Let's look at some of the graphical results. And why don't we start with the response-based charts. In Model Studio, those are called the lift reports. We'll go ahead and focus on cumulative lift, again, a common graphical tool. And rather than looking at performance on all partitions, let's just focus on the validation partition. Each model is represented by one line here. And it looks like no matter what depth I'm at on the horizontal axis, I can even zoom in a little bit. Looks like no matter how deep I am in the data, it looks like that orange line is always on the top. It's always giving me the highest cumulative lift. And that orange line looks like it comes from the gradient boosting model. So based on cumulative lift, it looks like gradient boosting model is the best model throughout the entire data set. How about ROC? I'll maximize the ROC reports and focus on ROC. And again, let's just focus on the validation data. And we're seeing something similar here. Based on different cutoffs, no matter what cutoff I'm at, It looks like that orange line is always the one that's closest to that upper left-hand corner. And that orange line is again describing the performance of the gradient boosting model. So in this first pipeline, whether I'm looking numerically, whether I'm looking graphically, it looks like there's an overwhelming winner from the first pipeline. It looks like the gradient boosting model. Let's take a look at the second pipeline. Maybe in the second pipeline, I've got a little bit more time to build the model, so I do a little bit more data preparation. We have a decision tree in this pipeline, 2 regression models, and a neural network. And the regression models and the neural networks require more data preparation. So we've imputed to correct for missingness. I've even used a variable selection node to select variables before the neural network in one of the regression models. And let's do some model comparison in this pipeline. Remember, Model Studio is going to use KS by default to pick the champion. And in the model comparison table, it looks like the stepwise logistic regression model is the champion based on KS. Again, bigger is better. But what about misclassification rate? What if I was interested in misclassification rate? Their smaller is better, and it actually looks like the decision tree has the smallest misclassification rate. What about some of the other statistics? I'll maximize that table. Let's look at good old average squared error. Again, smaller is better. And it looks like we've got 2 models that are tied on average squared error, the stepwise logistic regression and the forward logistic regression. What about area under the curve? Bigger is better there. There it looks like the second regression model, the forward logistic regression model, is the best for area under the curve. So as we're looking numerically at things, there's not one clear winner from this pipeline. It kind of depends on what statistic I'm looking at. What about graphically? We'll start with cumulative lift just as before. And we'll focus just on the validation performance. And here, well, it looks like it depends on what depth we're at in terms of what line is on best. At some of these shallow depths, it looks like the green line is on top, and then maybe the blue line is on top for a little bit. Then the orange line is on top, then the green is back on top. So based on cumulative lift, it does not seem that there's one obvious winner here. Sort of depending on where we're at in the data, one model might be better than the others for cumulative lift. How about ROC chart? And maybe you can anticipate what we're going to see there. Let me maximize that, go to ROC, and focus on validation data. The ROC chart is measuring true positive versus false positive rates for different cutoffs, and I'm not seeing one line that is always on top of the others. For certain cutoffs, it looks like even the orange line might be on top for certain cutoffs, then the green line, then the blue line. Of course, there are 4 lines here. The regression models are performing similarly, but there are 4 lines, one for each model. So based on ROC performance, I'm not seeing one model that is really the clear winner. So what I'll do moving forward is use the model that Model Studio is suggesting based on KS, which is the stepwise logistic. But maybe here's where we go down to the boss's office. Hey, boss, I've got a pipeline here, and I've got 4 models that I'm not seeing a clear champion there when I'm comparing them. Maybe we might use interpretation. Maybe we want to use one of the other models based on being more interpretable moving forward. That might be the decision tree. We can come back to that later, actually. Right now, we'll just move forward with stepwise logistic regression. So we've got a champion model from each of the pipelines, but in Model Studios, we can determine which is the champion of champions. Let's have our 2 champion models battle it out in model comparison. So here I'll go to the pipeline comparison tab. And at the top, we see our two champion models, even what pipelines they came from. Again, the computer's got to use only one piece of information, so it's using KS to pick the champion, which is the gradient boosting model. Now at the bottom right now, we're just seeing information just about gradient boosting model because that's the one that's selected. And a lot of this information would be the same information we saw from the pipeline that it came from. If I scroll down and looked at the lift reports, ROC reports, even the fit statistics, those would be the same as the values in the graphs that we could have seen earlier from the pipeline itself. Let's compare the two models. So I'm going to select both models at the top, and then I'll click compare. And now we're actually comparing the two champions head to head. Let's take a look at some of the fit statistics. Just be careful, this table gives training and validation. Say we're looking at average. We know that based on KS, we know that the gradient boosting model is better than the regression model because it's what Model Studio picked. Average squared error, smaller is better, and it looks like the gradient boosting model has a smaller average squared error than the regression. How about area under the ROC curve? Bigger is better. And oh yeah, once again, it looks like the gradient boosting model is better than the regression model. So numerically, it's looking like the gradient boosting model is the more clear winner of these two. What about graphically? Let's start with cumulative lift and focus on validation data. And it looks like that teal green line is the one that has the highest cumulative lift no matter what depth we're at in the data. And that line is for the gradient boosting model. So it looks like throughout the entire data set for cumulative lift, gradient boosting model seems superior compared to the stepwise logistic regression. Even though you might guess what we're going to see on ROC, let's take a look. I'll maximize the ROC reports, focus on ROC. And again, let's just focus on validation data. And once again, no matter what cutoff we're using, it looks like that teal green line is always giving us the better performance. So for true positive versus false positive rates, it looks like the gradient boosting model is the clear winner compared to logistic regression. So when we're comparing the champion of champions, it looks like the clear winner is gradient boosting. What's nice about Model Studio, though, and what you might be interested in doing at some point when you're doing model comparison, is bring a challenger into the competition. Remember when we went down to the boss's office and didn't have a clear winner from Pipeline 2, maybe the boss said, I like the decision tree because it's the most interpretable. You always got to keep the boss happy, so no problem. We can bring the decision tree in as a challenger model. So I'll go back to that pipeline where the tree was. I'll add it as a challenger model. I'll go back to pipeline comparison. And again, based on default KS, the gradient boosting is still the champion model. If I selected all three, maybe I wanted to look for the overall champion from these three. I could compare the models, and even though the decision tree is probably not going to be declared the overall champion, we've made the boss happy, and when the boss is happy, we're happy.